Hello, welcome to week 5 of construction print reading. This week we are going to talk about foundations, their importance, how they work, and how we read them on prints. So far we've talked about surveys, about their need in design, construction, closeout, how we create them, and how they fit with plot and site plans that show the size and the shape of the property, the shape and location of buildings, maybe the relationship of the building under consideration to other structures on the site, any grading that may be necessary in completing the project, the installation of utilities. So now we're going to start building the structure, and the first thing we need is a foundation. There is a companion presentation here concerning the Leaning Tower of Pisa, which gives an indication of the importance of foundations in construction. Let's start with the brick veneer sheet number 1. This is the basement plan and floor plan. This sheet actually contains 2 separate drawings that we will use. This week we're going to concern ourselves with the basement plan. Notice scale 1/4 inch equals 1 foot. First, let's talk about something called wall footings. These are concrete strips that are placed underneath a wall. It's a rectangular cross section, and it is symmetrically placed with respect to the wall. It will project an equal distance from either side of the wall, and it acts as a cantilever from both faces of the wall. The width of the footer is determined by the load and the allowable soil pressure, hence the presentation about Leaning Tower of Pisa. The allowable soil pressure is usually expressed in pounds per square foot. And the idea behind the footer is to resist overturning. When I have a wall sitting on a footer with holding back soil in this area, there's a natural tendency for the wall to overturn. However, the presence of the footer with the weight of the soil on this end and the pressure from the native soil below will resist that overturning. So let's go back to the brick veneer basement plan. The plan, as a plan view, only shows us the view as if we were looking from above. So it shows different widths of the footer and the wall. Notice this wall here is 1 foot wide, and the footer extends for 8 inches on either side of the wall. As we turn the corner, we see that the wall has been reduced to 8 inches, and near the corner the footer extends for 8 inches on either side of the wall, but further down the extension of the footer is reduced to 4 inches. Now, what it doesn't show us is how deep the footer has to be or how high the wall is. For that, we'll have to look at a different plan. Now, here we see the scale. Sometimes the scale is shown in the title block. Sometimes it is shown for each detail. Oftentimes, a drawing will say NTS for not to scale. At that point, you do not rely upon measuring anything on the drawing. You rely upon the numbers that are shown. So now we turn to brick veneer number 2, sheet number 2. Now we have elevations showing us the side view of the residence. And we can see in dashed or hidden lines how deep the footers or foundations will go. So we look at the right side elevation and the left side elevation. Here's the right side elevation, and it says that my wall is going to be 3 feet 4 inches below ground, and my footer is 12 inches thick. Notice there's a step here and a step here. We can calculate, if this is 2 feet 8 inches and this is 3 feet 4 inches, we can calculate. Notice the extension line here measures my 2 foot 8 from the same line as my 3 foot 4. Well, 3 foot 4 is 40 inches. 2 foot 8 is 32 inches. That tells me that this step here is 8 inches, even though it is not marked. The wall is letters denote the type of wall it is, and CMU stands for concrete masonry units. Notice on the left side we have the same 2 foot 8, but now my 3 foot 4 inches has its own step. So my 3 foot 4 inches now is measured 8 inches below, which makes this distance from this point to the top of the footer here only 24 inches or 2 feet. Since this is already 40 inches, that makes this step 16. So even though both the right side and the left side elevations look to be the same, they are in fact different. Now, looking at the rear view, we can see that the basement, the footer ends 7 feet 4 inches below ground with another 1 foot, so the base of the footer will be 8 feet 4 inches. Here's my concrete masonry units, and notice the wall is concrete masonry units, the footers are concrete. And concrete masonry units, by the way, is just another term for cinder block. Here my left side elevation is drawn to a scale of 1/4 inch equals 1 foot, but my right side gable overhang, a detail, is drawn to a scale of 1.5 inches equals 1 foot. Again, just a reminder to always check, because all items on a drawing may not be drawn to the same scale. Now, here's back to the plan view of the brick veneer basement. We have a crawl space, and it says excavate to the top of the footings. So we can use our elevations to determine how deep that crawl space is. That means, however, that the crawl space will be excavated to the top of the footer, so the footer will extend another 1 foot below the bottom of the crawl space. So let's take a look at some of the details that are shown here. Here's our 3.5 inch standard pipe column, our footer. Here's another example of where the pipe column is. And here's the detail on back in the corner of that same page. Notice it's drawn to a larger scale, and it's a typical basement column, which means wherever we see a column, this is what we want it to look like. Here are the 2x10 wood joists that sit on top of it, and we'll talk about them some more in framing. Notice the break line, because I don't need to draw the rest of that joist. Here's my 3.5 inch standard pipe column, and again, I have a break line because the space in here looks just like this and looks just like this. And since it's drawn to scale, I don't need to waste the space for the full 2 feet 9 inches. Here's my concrete footer. And here's my W8 by 17 wide flange beam. And we'll talk about wide flange beams a little later. And here it is called out in the plan. This is a detail from Trade Plan 2, a residence. This was once part of the drawings that came with the text, and I do not believe it is part of the drawings you receive. Therefore, it is included under handouts so that you can take a look at it along with me. What I wanted to point out to you was the foundation details that are shown and this item called a keyway. Notice the little notch here. This provides a mechanical connection so that pressure against the wall here will not allow the wall to slide because there's this mechanical notch. Notice we have an expansion joint between the 6-inch concrete slab and the wall. So as the slab or the wall expands, there is something to absorb that pressure and not force itself directly against the concrete, perhaps causing it to crack. Again, we see the use of break lines. Notice here is a survey marker. And again, this is an indication of the legends and symbols that may sometimes be used in one situation and used differently in another situation. Sometimes these are used to indicate where a soil boring is located. So you always have to use a little common sense and determine what your drawing is trying to tell you. Let's look at branch bank sheet A1, again included in your handouts. We already talked about the site plan. Now we're going to talk about the foundation plan. Now, so two areas that I want to discuss with you. This note down here and these notes here, and some information about the teller pit. Here we have the teller pit. The slab specs: a 4-inch concrete slab over 4 mil, and a mil is 1/1000th of an inch, PE, polyethylene vapor barrier, and at least 4 inches of crushed stone. We will talk a lot about maximum and minimum. And when you come up to something that says at least, it means you can have more than 4 inches, but you cannot have less. Notice we are looking at 3 number 4 bars continuous in wall footings. At a column footing, I want 4 number 4 bars across, and the masonry reinforcing in alternate horizontal joints in CMU foundation walls. So every other layer of cinder block will have a reinforcing through it. And we'll talk about this in just a second. Here we have a section A1, 1, and when we have a cutting plane, remember our cutting plane line, this arrow tells me that I am standing here looking in this direction. Someone has taken a slice through here, and I'm on this side looking over here. So on my left-hand side, I will see this wall. On my right-hand side, I will see this wall. Again, we want to make sure all our things underground are in place before we start covering it over with concrete. A little bit about welded wire fabric. It is sometimes referred to as wire mesh. Originally, it was measured or designated by the gauge of the wire, such as 12 gauge wire. 1970, ASTM changed to a numbering system that relates to the cross-sectional area of the wire. So a W means it's smooth wire. D means there are bumps. It's a deformed wire. And the number following the letter gives the cross-sectional area of wire in hundredths of a square inch. And so that's done because it's easier when you're designing and you have to know how much steel is going to be in the area. So here is our section through the teller pit. Here's my welded wire fabric. Notice it says WWR, as in welded wire reinforcement. 6 by 6 is the dimensions, the size of it. W, it's smooth wire, 1.4 thousandths of an inch cross-sectional area. Notice my 3 number 4 bars talked about here. Remember, the building is over here because we are looking through, here's my A1 section, and tells me 12 inches PVC to the future island. There may be something here later, and we are putting 12 inches, a 12-inch diameter PVC pipe through here so that I don't have to dig up the asphalt paving when I install it. It's already there, and this has already been built. Let's turn to Wendy's sheet 3. Want to draw your attention to the notes. Whenever you get a drawing that has notes, look at them because they may contain information that's not shown on the drawing. Notice it says here all footings are 20 inches by 8 inches. So that would be 20 inches wide by 8 inches thick. 2 number 4 bars. They are continuous unless noted otherwise. So if I don't have that size or that number of bars, there'll be a note. Verify the depth of the footing below grade with local code. There's something called the frost line. And above the frost line, the ground has the ability to freeze. And when it freezes, it expands and it's going to move a foundation. So you want to build below the frost line so that there is no movement. In an area such as Florida, my frost line is very, very close to the surface. You're not going to get freezing to a great depth. Here in Ohio, that frost line might go down as far as 3 feet. So you have to excavate below 3 feet. Interestingly, it's a reason why in areas such as Florida, you don't find a lot of basements because it's not necessary to dig down that far. If you've already dug down 4 feet or so in order to get below the subgrade, or the frost line, it's no big deal to excavate another couple of feet and build a basement. Concrete block coursing starts at the top of the footing with CRS number 1. Well, we're talking about concrete block coursing, so maybe this is course number 1. We'll see what that means in a minute. See electrical sheets for locations of conduit runs. So remember rule number 1. You're the foundation contractor, so I give you this sheet. Well, you haven't got all the sheets. You need to see where the conduits are. Again, why? Because we don't want to be installing foundations and then have to dig them up in order to run electrical conduits through. All footings are designed for 3,000 pounds per square inch. Soil bearing pressure. but you need to verify soil bearing capacity before placing footings. We may not have the tourist attraction today that the Tower of Pisa is, had the contractors done this back in the 12th century. So once again, I have cutting planes, and that's telling me that I have taken a slice through here and I'm standing here looking in this direction. Notice it refers to foundation note 6. We will find these details F and E on sheet 7B. That's what the 7B stands for. So again, the way this is looking, I'm on the outside, so the interior of the building is on my left. So here are those two details on page 7B that we saw from the cutting planes on sheet 3. So we look at it a little more closely. Notice the number 1, 2, 3, 4. This is the courses. And remember it said start with course number 1. So notice that when we get to course number 4, we go from a 12-inch concrete block to an 8-inch concrete block. Here are my rebars, 20 inches wide by 8 inches deep, concrete footing, 2 number 4 bars, continuous. Now, we will talk about what's in the framing when we talk about above ground structure. But I just wanted to point out that going from right to left, I have here a brick veneer. I have sheathing. I have a layer of felt secured to the sheathing. I have the studs. I have insulation. I have a vapor barrier, or actually a vapor diffusion retarder, which reduces the rate at which moisture is going to be able to move through the material. Notice it's either moisture-resistant plywood or Durock, which is basically a cement board, and then a wall covering or paneling. So we need to see this section in order to determine how the wall is put together. That ends week 5 presentation. Please see the presentation on the Leaning Tower of Pisa.